Okay, so this week our interactive case study is on the cancer drug Fluorouracil or F5FU, also the trade name Adrasil, so it has about three different names. So, just a little bit of background on this drug, 5FU Adrasil or Fluorouracil. It's been around for a while. It was discovered 50 years ago. It's kind of become a mainstay of chemotherapy regimens and solid tumor cancer treatments. This is important. It's a member of the fluoropyrimidines, and as you recall, pyrimidines are cytosine, thymine, and uracil. So this drug is considered an anti-metabolite drug. It enters the cancer cells and it interferes in their ability to replicate. It impedes the metabolism, the cancer cell metabolism. So, more in terms of the mechanism of action, it mimics the pyrimidine compound. This drug is most often given intravenously and oftentimes also in conjunction with other cancer drugs. We've studied some of them already in our case studies. So, how the fluorouracil inhibits the RNA synthesis. So, in terms of the mechanism of inhibition, fluorouracil essentially inhibits the enzyme which is responsible for catalyzing the thymidylate. In this enzyme, they call TS or thymidylate synthase, and it is what controls the protein synthesis and the apoptosis in the cancer cells. So TS catalyzes DUMP, DTMP, and these intermediates are help to maintain DNA replication and repair. So with this drug, the specific cascade of action cannot take place, and so the cancer cells are not able to proliferate. And the inhibition of the enzyme TS proves fatal to the rest of the RNA or DNA process to proceed in the cancer cells. So, oh, sorry. I think this is a really good slide. I took this slide from some of my research, but this just shows you in a bit more detail how the fluorouracil is metabolized by the cells. You've got catabolism and anabolism. You have the intermediates, you have the kinases, the thymidine phosphorylase, and you could just take a look at this flow chart in greater detail to kind of see how the RNA and the DNA synthesis are blocked and where the intermediaries kind of fall in with the uridine kinase and preceded by the uridine phosphorylase. Okay. So 5FU is converted into three specific different analogs. Those were shown on the previous slide. And then in some places they call them FDUMP, FDUTP, or just fluororidine triphosphate. So because the 5FU drug is so similar, the analog property to the thymine and the uracil, the nucleotides, it significantly disrupts the DNA synthesis, and that is why it has such promising results especially in colon and breast cancers. And as we saw, it leads to greater reduction over 50-60% in some cases. And then that's just the works cited.